All right, this is 5.6, number 8. And what they're asking us to do is factor the trinomial. So we say it's prime if you can't divide anything out of 5x squared z, 55xz, and 90z. So you're thinking of these as each of these is a term. So you have this term, and this term, and you want to find a common factor of each of those terms. So if we think of 5 and we make 5 into the factor tree of 5, 5 is a prime. And so when you see on MyMathLab, one of the choices is they write this and then they say equals, but then the second option is they write this and they say is prime. So prime means you can only multiply it by itself times 1, okay? So the prime factorization, or sorry, the factorization of 5 is just 5 and 1, or 5 is prime. The factorization of x squared is x times x, right? And then z is just z times 1. So z is prime. Prime, that's the most basic factorization. Those are the smallest factors you can get. And then z is also prime. So you can do it to the next one. The next one was 55xz, right? So now if we take 55, I think it's smart we started with our smallest number. We have a 5, a 55, and a 90. Take that smallest number and see if you can divide your other two terms by that number, because we're looking for common factors. So if I can say that I can divide this number by 5, I can divide this number by 5, and I divide this number by 5, that is how you factor. So if I take 55 and I divide it by 5, I get the number 11. Good. So 55 is 11 times 5. 11 is prime and 5 is prime. So that's my simplest factorization of 55. X remains x, and z remains z, right? Or z times 1, which is the same as z. 5 times 1 is the same as 5. So I'm just going to call these x and z. And then we have 90z. To factor. Again, since we have 5 that's common here and common here, I want to take 90 and divide it by 5. 18. So 90 is 5 times 18. Oops. We can continue factoring 18 if you want. So we'll just say that remains 5. 18, probably 9 and 2. 5 remains 5 because it's prime. 2 is also prime. So now it's 5 times 2. 5 times 18, or 5 times 2 times 9, will equal 90. 5 times 2 times 3 times 3. Good. So once you get to the bottom of your factor tree, none of these numbers can be divided by anything. And once you multiply them all together, you should get that same number you started with. Good. So 5 becomes 5 times 1. 55 becomes 11 times 5. 90 becomes 5 times 2 times 3 times 3. Good. And then the z, again, just remains z. Good. So we have 5x squared z plus 55xz plus 90z, and what we translated it into was 5 times x times z, right? Keep that plus, and then that 55xz became 11 times 5 times x times z. Good. Keep that plus, and that 90z became 5 times 2 times 3 times 3 times z. Good. Now we have it in its most factored form. So now we want to divide it by a common factor. So the fraction bar is division. What is common to 5, 11 times 5, and 5 times 2 times 3 times 3? It's 5. So I can divide them by 5. And nothing else, okay? It has to be true for all 3 of them. The biggest number I can divide this thing by is 5. Good? What about the x? Here I have 2 x's, here I have 1 x, but here I don't have any x's, so I can't divide it by x, okay? What about z? I have a z here, a z here, and a z here. So since I have a 5, a 5, and a 5, I can divide it by 5. Since I have a z, and a z, I can divide it by z. So I look at 5x squared z, 55xz, and 90z, and mathematically I have figured out that I can divide them all by 5z, okay? When I divide by 5z, it means that the 5 that is common, to the top and the bottom cancel. 55 was 11 times 5, so 55 divided by 5 becomes 11. So that's like a 1, right? 5 divided by 5 is 1. 55 divided by 5 is 11. 90 divided by 5 is 2 times 3 times 3, or 18, right? So that became an 11, and that became an 18. That became a 1 for the 5. And then the z cleanly just cancels. Z divided by z is 1, z divided by z is 1, z divided by z is 1. So now I have 1 x squared plus 11x plus 18, and I need to put the 5z outside. So what I'm saying is 5x squared z plus 55xz plus 90z is the same as 5z times the quantity x squared plus 11x plus 18. Okay? If I were to distribute this, I would get back to this answer. Also, if you wanted to do the same thing up here, so up here it was 5xz divided by 5z plus 11 times 5 times x times z divided by 5z. Sorry, sometimes I'm putting a multiplication sign, sometimes I'm not. Plus 5 times 2 times 3 times 3 times z divided by 5z. When I cancel the 5, it's a little bit faster. When I cancel the z, and then I'm left with x times x is x squared, 11 times x is 11x, and then 2 times 3 times 3 is 18. 3 times 3 is 9, 9 times 2 is 18. And then again, I have to put the 5z outside of that. All right, so that's the first step, is we factored out 5z. So we went from 5x squared z plus 55xz plus 90z. We simplified that too. We divided out the 5z. And we said 5x squared z is now x squared. 55xz is now 11x. And 90z is now 18. Okay, now we are going to factor a trinomial and see if we can factor it into 2 binomials. Okay, so for this we have ax squared plus bx plus c, right? So in that format, we know that a in this case is 1, b is 11, and c is 18. What we need here is for any 2 numbers that multiply to equal a times c, and that add to equal b. In this case, a is 1, and c is 18. So they multiply to equal 18, and they add to equal 11. So multiply to equal 18, add to 11. Now I'm just going to list, like we made a factor. So this would be a factor tree of the number 5, a factor tree of the number 90. Now we're going to make factor pairs, which is the two numbers that come together to equal 18. So a factor tree might give you 3 numbers or 4 numbers, whereas factor pairs are just 2 numbers. So the 2 numbers that I can multiply together to get 18, and I'm going to use positives because these are both positive terms, okay? So 18 could be 1 times 18. 18 could be 2 times 9. And so that's what I do is I just go start at 1, go to 2. Can I divide 18 by 3? 18 is 3. So what I'm doing is I'm just starting with my number, divided by 2, divided by 3, divided by 4. So 3 was 6. 4 was not a whole number. 18, I don't think it's going to be divided by 5. And then 18 divided by 6 is 4 again. Sorry, 3 again. So I'm back. I just keep going down. 4 wasn't an option. 5 wasn't an option. And then 6 is already one of my pairs. Okay, so I know that I've found all my pairs that multiply to equal 18, except for negatives, right? -1 and -18. But those 2 negatives will never add to a positive 11. So I'm not going to include those, but they do exist. But I don't need to use those. So if I add any of these, will they add to 11? 1 plus 18 is 19, that's not 11. 2 plus 9 is 11. 6 plus 3 is 9. So these 2 pairs multiply to give you your third number, or your third number times your first number, and they add to give you your middle number. So what we do with them is we say that x squared plus 11x plus 18 is actually x plus 2x plus 9. So x squared plus 11x plus 18 is, and you could even set it up like this until you find your 2 terms. But once you find them, then you say this is a positive 2, so we're going to say plus 2. This is a positive 9, so we're going to put a plus 9. And that was just the middle term, so we're also going to include that 5z times x squared plus 11x plus 18 is equal to 5z times x plus 2 times x plus 9. Good? And you can check your work, right? So if I have x plus 2 times x plus 9, I said, based on this rule, that this will equal x squared plus 11x plus 8. Let's FOIL it and find out, okay? X times x is x squared, x times 9 is 9x, 2 times x is 2x, and then 2 times 9 is 18. When I add 9x and 2x, I get x squared plus 11x plus 18. Good? So those were those 2 multiplied together. Now I'm going to multiply all of that. Make sure you use the parentheses. Multiply all of it by 5z. Hold on. Multiply all of those by 5z. So when you're multiplying a binomial times a trinomial, and we need to send the 5z to all 3 places. So 5z times x squared is 5x squared z, right? 5z times 11x, 5 times 11 we know is 55. xz, and then finally 5z times 18 is going to be that 90z. So we know that 5z times x plus 2 times x plus 9 is the factored form of 5x squared z plus 5zx, plus 90z.